Our Federal Railroad Administration Electronic Control Pneumatic Brake System Freight serve the following report. Section 2, Rail Brake Operation Safety Impacts. Rail brake operation safety impact with the understanding of the economic benefit of the with electronic control pneumatic technology with the necessary for the appreciation of the whole conventional brake technology currently works in the U.S. rail freight industry, but the technology is important in many aspects of the rail operation safety. What would change with the electronic control pneumatic operation? Section discover the technology in summary with the appendix A with providing more of the detailed treatment of the history of the rail brake technology, earliest application throughout the current electrical control pneumatic performance. And 2-1, how will the rail brakes currently work? With George Westing developed the automatic brake system in the 1870s, found with the subsection summarized how it would work. Figure 2-1 and 2 through 2, figure 2-3 demonstrates automatic air braking stages, conventional air braking system charge, locomotive of the air compressor charge of the main reservoir to about 150 psi per square inch. Control locomotive charge of the brake pipe of the air from the main reservoir on the locomotive of the brake pipe. Single pipe with 1 1/4 inch of the diameter runs the length of the train with the connective between the car of the brake pipe hoses. Each car has 2 compartmental auxiliary reservoirs that is charged with the air brake of the pipe at the same pressure for the 90 psi. Each car with the brake cylinder have the connective with the series valve with the levers and applied with the release of the brake with the pressure that's applied with the brake cylinder with the resulting force. Brake shoe against the wheel with the brake force resolved. With the brake application correct with the control value with the successor George Washington triple valve. The automatic air brake system charging locomotive control main reservoir brake pipe, the auxiliary reservoir with the brake cylinder, brake shoes, and car number 1, 2, and 3, and so on. So for the brake application, with the control valve directs for the air from the brake pipe with the auxiliary reservoir with the air pressure resolved with the brake pipe in order to charge with the auxiliary reservoir, be ready for the brake application. Perform the brake application locomotive automatic brake will reduce the pressure of the brake pipe by exhausting the air. The drop pressure of the brake of the car control valve to direct the air from the auxiliary reservoir to the into the brake cylinder. The pressure of the brake cylinder with the approximately proportional drop of the brake pressure. A 26 psi reduction in brake pipe pressure is equal to the full strip of the brake application. Fully charged brake pipe NA should result with the brake cylinder pressure adequate to achieve full strip of the braking effort brake force. While in the control valve with the directing air with the brake cylinder holding the air and brake cylinder is not able to recharge with the auxiliary reservoir on each car, the engineer can apply with the brakes increments of a few psi at a time and go directly into the full serve of the application 26 psi reduction. The figure 2 show the automatic air brake application locomotive control valve with the main reservoir with the brake pipe exhaust of the brake pipe from car 3 to car number 2 to car number 1. The AB valves and the brake cylinder brake shoe is given from the auxiliary reservoir when the exhaust is given in the main reserve of the control valve of the locomotive. 2, 1, 3, brake release. So the brake application relief of the brakes cannot be performed in increments. The brakes can only be released to zero. The direct relief of the auxiliary reservoir then begin with the charge of the brake application. Powerful, the more complicated with the undercharged brake pipe reservoirs. Recharge if it takes more time, the longer the train becomes the air has too much set down length of the train pipe, and which can be up to 1.5 miles. 11.3 show the automatic air brake brakes relief. The control locomotive with the main reservoir with the brake pipe then to the car number 1, the auxiliary reservoir cylinder exhaust with the brake cylinder on the brake shoe. And then it continues down the train to car number 2, number 3. It is an extremely long train with a brake pipe pressure for the last car, but it may not reach the 90 psi due to the small leaks through the brake pipe. There may be problems getting enough of the brake pipe pressure to fully relieve the brakes during cold weather. 214 emergency brake application. Emergency brake application can be initiated in several ways. The locomotive engineer can initiate with the application, move with the brake hand with the emergency position, with the exhaust of the air of the faster rate, with the servo the application for the control. Director's valve located in the cab of the locomotive can be open and initiated, but the emergency brake application can also be initiated by a brake-in tube where the train breaks into between the 2 cars. The brake pipe hose is separated with exhausting brake pipe pressure. Operating under electrically controlled pneumatic brake technology. Electrically controlled pneumatic brakes so they overcome the physical limitation inherent with the conventional with the air brake technology, the use of the electronic transmission for the brake signal through the train with the still use of the air pressure for the considered cylinder to apply with the force of the brake shoe with the electronic controlled pneumatic brake also should signify the extent of the multi-value with the equipment with the conventional brake with the reduced with the printed circuit, more with the micro prop with the 1 electrically activated application value with the 1 electrically activated release valve. With feedback over the brake cylinder, the pressure of the control, the 2 slightly different arrangements with the electronically controlled pneumatic system that meets the AR standard. The first over the standalone system replaced with the pneumatic logic completely, allowed for the cars to operate with the electronically controlled pneumatic brake mode. The second overlay system, which will overlay the electrically controlled pneumatic logic on top of the existing pneumatic logic, allow for the cars to be operated either in the electronically controlled pneumatic or the eventual pneumatic mode. The electrically controlled pneumatic equipped car may be hauled with the train operating with eventual modes of the vice versa. The operator of the electronically controlled pneumatic available electronically controlled pneumatic must be installed with the locomotive as well. With the freight car, the figure 2.4 shows the key locomotive of the freight car component of the electronically controlled pneumatic system. Key locomotive freight car components of the electrically controlled pneumatic system. Control device for the train power supply. The car ID module, car connector to operate interface unit with the train line communicator, control and the brake. The operating benefits of the electronic control pneumatic technology. Electronic control pneumatic technology offers a number of the distinct benefits compared with conventional rail freight train braking technology. Brake signal transmission rate with the degree of electrically controlled pneumatic conventional braking with the air signal transmitted the braking communication approximately 2/3 of the speed of the sound. The time is with the air signal will reach of the last train that is much lower than the electronic controlled pneumatic brake application release. The signal of the electronic controlled pneumatic signal transmitted electronically hence of the instantaneous allowed with all the car even with the longer the freight train to brake together, significantly reducing in force of the push and pull of the cars against each other. The trains both rail equipment and cargo. Brake application rate with the control of the electrically controlled pneumatic technology. One each of the freight car of the train. Receiving the signal with the rate of the air of the supply with the cylinder with the rate of the which of the pressure build up with control of the car is maintained same or closed brake cylinder pressure of the main point in time during the build up. They also produce the train and force with the car of the transit difference for the cylinder pressure conventional practices brakes. Graduated brake relief, the ability to reduce the practice of brakes with the lower braking up level after the braking application for the enable the adjustment of the brake level of the mode more closely have the safe speed of the ECP brakes for any train will have capability. A conventional brake operation, once of the operator with the toe of the brake level, cannot reduce the completely releasing and resetting of the brakes, which can only be safely be done with low speed. May give the leads to the unnecessary train stop, but may also lead to the operator making less brake application than needed initially, because it is always possible to add more pressure, but not to reduce it once applied. The lack of the graduated release has been long hampered train operation. Constant charging of the reservoir also featured the electronic control pneumatic brake technology for which the brake pipe act for the air as a reservoir supply pipe. Brake application significantly electrically does not reduce the brake pipe pressure for the brake pipe but continuously supplied with the reservoir with the brake application for the release gradually or by sudden total relief of the reservoir always recharge with no waiting with the risk or have with no brake pressure. Longer train lines have the are possible electronic control pneumatic with easily electrical signals instead of the air pressure for the brake applications of the brake pipe to be maintained full pressure at all times, but the uniform braking with a constant pressure reduced for the end of the train pressure for the problems for the in-train force restrict the current train lengths. However, the average train speed, but they are possible in some cases due to the higher maximum speeds. They all the capable do better to apply. Ability to follow the speeds, limitations, ability to perform graduated release allow the engineer to produce the brake application whenever they're too severe. Thus, there is no need to travel the distance if the too slow for the speed because of the inability for the bank of the brake release. The shorter restarting time is after the train stop of the air achievable to pull under with the electronically controlled pneumatic brake operation with the current brake technology auxiliary reservoir at the end of each of the train must be recharged with the brakes reset, ready before starting with the train with the proof of the brakes were assumed with the required with the dust in the air with the now descending with the grade with the waiting period before the train can proceed with the end after stopping the route with the electronically controlled pneumatic brake with the pipe with the brakes for the down lowered with the brake application instead of electric leakage or signal with the transmitted down with the train wire indicate with the brake application with the brake pipe remains charged 90 psi for that continue with the supply with the reservoir during the braking hence for the no need for the downtime for recharging after the braking. Eliminating power brake with the speed for the unconventional with the technology when the braking with the produce the signal ahead with the show with the curve with the switch with the locomotive with the engineer with the maybe to have to apply more brake after with the required with the slowdown far ahead with the speed with the restriction. The engineer cannot be relieved of the brake for the shaft and may not be able to recharge with the reservoir in full time safely negotiate with the restrictions so applied with the locomotive. Properly while the brakes are applied with in order to optimize the speed of the power braking with the bolts of the wasteful with the as well with the unnecessary wearing of the brakes as well as possible the wheel damage of the fight with the locomotive pull with the gradually relief the engineer could simply reduce the braking force in order to optimize speed. Reduction undesired emergency with insignificant benefit of the electronically controlled pneumatic technology. Undesired emergency with the expected with the unwelcome of the train stop due to the sudden loss of the air pressure Brake pressure for the current brake technology is built with the behavior of the complex system of the air valve with the spring with the capture volume for the air with the turn pressure for the diaphragm between the air with the volume and check valve. Mechanical technology varies with respect with the temperature for the cleanliness of the air with the wear of the rubber component of the inevitable leaks. Displayed with the constant improvement of the valve technology, many of the remain with the unintended with the emergency brake application initiated by removing many of the value of the turning back brake application electronically rather than the air pressure for the electronic control pneumatic brake technology sharply reduced with the undesired emergency thus improving the train performance and throughput, reducing delays in on severe grades. Also available with electronic control pneumatic with the current brake technology on long time and steep the descending grade of the brakes is set with the top of the cannot be relieved with the train reached with the bottom of the grade comes to the top of the reserve cannot be recharged while the brakes are applied with the potential for the leakage of the system of the brake, bringing the reservoir pressure down onto a level the insufficient makeup of the top of the region with the retainer would develop the retainer the divide of the brake cylinder exhaust that when it's set with it will maintain a minimum of approximately 13 psi of the brake cylinder even when the brakes of the train are released. Therefore, the brakes are going to be released with the reserve constantly recharged with the retainer over the valves up to 13 psi with the cylinders. More braking can also be added with the need of the never to drop below 13 psi when released. The need of the retainers must be manually applied on every of the train with the top of the hill. Retainers must be then released on every of the train with the bottom of the hill, along with 100 plus car trains. This means walking over the 2 miles, repeating 120, 200 retainers, switching with a considerable amount of time spent eliminated with electronic control pneumatic brakes. And some of the operating benefits of electronic control pneumatic brakes of the most diverse significant. The operating benefits translate major economic benefits of review of the Section 3 of the report. 2.4 Safety benefits failure rates of the electronic control pneumatic brake technology operating freight train with electronic control pneumatic brake yields the number of the significant safety benefits listed below the summarized in figure 2.5. Electrically controlled pneumatic operate shorter shopping distance, improved train handling, continuous brake pressure, train monitoring, impact avoidance of some of the grade crossing accidents, the training of the train collision, reduce the crew fatigue of the train, the chance of the derailments, ability to stop the train and maintain at all stops times, brake function over the confirmation of the opportunity to add the train performance functionality, stopping short stopping distance due with reduce the time of the brake signal with the transmit with each of the car longer car with the stopping distance with the long train with electrically controlled pneumatic brakes. You can up to 40 to 60% of eventual braking stop distance in the inside of the air. New York air brake found with a loaded 100 car train moving at 15 miles per hour requires 100 feet to stop with eventual brakes compared to 2,500 feet. Electrically controlled pneumatic reduction with the nearest 40%. Short stopping distance available with electronically controlled pneumatic brake offers the major safety benefits. Help with the reduced collision grade crossing accident for the engineer was able to see the threat of the tracks. Could not stop with the train with the time with the conventional brake with electronically controlled pneumatic brakes along ahead with the train will not be able to stop on the dime, but will reduce the range of the shop stopping distance to help avoid some of the accidents and above the about 1,600 feet near a third of the mile with a serve the ACP could help an train engineers made grade with the crossing situation, clear line of sight, short stop, hitting an object within crossing. Improved train handling with the reduce the derailments caused with the train surface with the current brake with the technology first car train with the began with the brake with the first of the braking initiated with the progressively back through the train with the result of the car with the back of the train running faster than the car than the front of the train with the sometimes compressing the train improve the potential for the car in the middle of the braking train with a squeeze of the both ends of the end of the curve with the jump of the outside of the rail with the cause of derailment. Electrically controlled pneumatic equipped cars with the wheel brake simultaneously so that there is some running in through the different braking of the car with the length of the train. Improved train handling will also lessen the chance of the operating error of the operating of the train with the current brake technology extremely complex and task requiring extensive knowledge of the rail line over the train is running with the constant pre-planning of the train speed with the braking options several plans ahead. For example, on the grades of the operator constantly watching the gauge of the monitoring speed with the air pressure for the dynamic brake after the must be prepared to make decisions instantaneously showing that something is wrong. On level track consequent with the improper train handling with the conventional technology not necessary with the train with the unstoppable with the rabbit within the train path with the extreme with the entire with the track with the another trains occupying with the engineer constantly making adjustment of how with the main brake pressure with the apply with knowing with the effort cannot be produced. Once committed with it can call with the locomotive engineer to decide with one on less pressure when braking, assuming that perhaps unless wisely with the braking effort can also be added when the time when needed. Entire process becomes greatly simplified with controlled pneumatic brakes because the engineer does not need to worry about applying with too much brake effort. You only get gradually relief of the brakes at any time. Train monitoring Will have the electronic control pneumatic brakes to inform of the function of the air of the brakes at all time. When any time of the brakes are applied, with the engineer immediately re-informed of the air brake. Any brake failure with any of the car with the train does not have the depending on the current braking physical inspection after every 1,000 miles of the trip. Continuous brake pipe pressure provides ability to stop the train at all times. Remove the threat of the premature deletion of the air reservoir running air drain. Runaway train with the issue with the conventional brake technology, real-time train status reporting, possible utilizing electronically controlled pneumatic brake system, wire-based communication performance transmit information over each car back to the locomotive. This could include such information bearing condition, physical wheel problems, with resulting benefits of safety. Reduce train crew fatigue, also powered with electrical control pneumatic brakes over the non-definite data that has been complied with the side-to-side with the electronically controlled pneumatic versus non-electronic controlled train simulators operating on the BNS that indicate with electronically controlled pneumatic brake trains are faster, easily operated, but do not require the operator to constantly focus on the pressure level of the brakes, so they are always full. Each of the crew can concentrate with the operating environment and the train is located rather than in-house, so able to prepare likely brake pressure at levels miles ahead. With respect to the feature of the electronic control brake version of the conventional one, the Booz Allen has talked extensively with the brake manufacturers of the New York Air Brake and Wave Tech, the Quebec Carter Mining, which runs the electronic controlled pneumatic train within Canada since 1998, and attempted to reach for the Spornet, which was installed with electronic controlled pneumatic core export lines in South Africa. Fortunately, while these parties believe with electronic control pneumatic at least one serves no more than reliable conventional counterpart. No one in the real world operating data comparing future rates side-by-side train operation for two system one approach is seeing such data compatible with the first version BRB trains to ECP would allow potential unit to reliable directly compared reliably electrical pneumatic control technology concurrently AR compliant with the ECP equipment that heavy haul long distance coal movements of similar terrain. Section 3, ECP Electrical Control Pneumatic Implementation Costs and Benefits. Testing.